Hey everyone, my name is John, and we're going to talk today about designing great APIs. As a little bit of background, I work for a company called Brightcove. Brightcove does end-to-end video publishing for big media companies, enterprises, and small businesses, and startups, and all sorts of companies. I came to Brightcove via a company called Zencoder, which Brightcove acquired last summer. And Zencoder is an API-based product for video and audio transcoding in the cloud. So it's basically high-scale, high-performance video and audio transcoding. So I've been working on APIs for the last like 3.5 years. That's been my entire focus. Our product was an API. So today, when I talk about API design, I'm going to use some examples from the life of Zencoder, talk about my experience with this. But of course, I'm going to talk about other APIs as well and general principles too. So hopefully everyone here knows what API stands for. If you don't, this probably is not going to be the right talk for you. Who here has worked on an API before? Raise your hand. All right, that's like everyone. That's great. Who's worked on an internal kind of service-oriented architecture, internal API? What about an external productized API? So good mix. Everything we talk about, I think, will be equally applicable to both, and maybe we can kind of discuss differences between those approaches if we have time as well. As you all know, the I in API stands for interface. And an API is an interface. We think a lot about this as an interface. This is maybe a user interface. If it was the 80s, we'd probably call it a graphical user interface. Now it's just a user interface. But this is an interface as well. Who is the user of this interface? Developers. Any other users? Machines, software. I think every API actually has two users. And they both have different concerns. So there's software and a programmer. What does the software user want? What does the machine user want in an API? Data, consistency. What's discovery? Speed, change. Ultimately, it comes down to working the way that the machine expects. So syntax, correctness, efficiency, speed, scale, all those things are important to the machine user of an API. What does the developer user want in an API? Ease of use. What else? Simplicity. Clarity. Understandable documentation. Yep. Ultimately, what we want as developers when we interact with an API is we want our APIs to actually be designed. We want to recognize that this is an interface to us, and it's important to think about the developer user of an API when creating an API. Just as a user interface for maybe a website can help make a website easy to use, help people accomplish their goals, make it easy to understand, make it pleasant to use, the exact same things can be done with a good API design. So that's what we're going to talk about today. We're going to talk about it through three lenses. The first is George Orwell. The second is a guy named Dieter Rams. And the third is something called the Kano Model. Orwell is going to talk about writing, and we're going to see how that kind of relates to APIs. Dieter Rams talks about industrial design, and the Kano Model is a model of product development. Along the way, I'm going to pull out kind of 5 guiding principles that I think should guide every well-done API. We'll look at some specific examples and tips of maybe good and bad API structures. And hopefully I'll have some time for discussion, too. I've been working on APIs for about 3 years, and that's probably a tiny slice of like all the time in this room that has been spent working on APIs. So hopefully we can talk a little. So we're going to start with George Orwell. Orwell is best known as a novelist. He wrote novels like 1984 and Animal Farm that many of us, I'm sure, have read. But he was also an essayist, and he wrote what I think is one of the best essays ever written on the topic of writing. It's called Politics in the English Language. Why are we talking about writing? Quick answer is programming has a lot in common with writing. Programming is actually a form of writing when you think about it. Programmers take abstract ideas and make them concrete in a particular language. It's the exact same thing that a writer does. And so Ruby gives us a grammar. Ruby gives us a language in which we can write our ideas, create our processes, create the work that we want our software to do. What does an API do? I would argue that an API extends our language. It gives us new nouns and new verbs to be able to write things that are maybe more powerful than we could do without. So in Orwell's essay, he gives some examples of good writing and bad writing, gives some tips that we'll look at for writing with good style, but he also does something really interesting. He connects good writing to good thinking, and he connects bad writing to bad thinking, and says that that's actually a key tool of political oppression and totalitarianism. As an example of this sort of political writing and political speech, USA Patriot Act. What was this act about? 9/11? Not USA patriotism? This legislation was specifically given a name for the purpose of obscuring thought. You can't have a rational discussion about the pros and cons of USA patriotism if you're a United States senator. Instead, this label was this name was created to shut down discussion. So this is bad writing that creates bad thinking. A better name for this would have been something like maybe the Expanded Surveillance Act, something neutral and direct that we could have a discussion about. We could say reasonable people could discuss, should we expand surveillance in the wake of 9/11 or should we not? But a name like USA Patriot Act is written intentionally to prevent that. That's why Orwell says that bad writing is a key tool of propaganda. Here's an example he uses in the essay. Imagine this being written by a leftist professor in England in the 40s or 50s. While freely conceding that the Soviet regime exhibits certain features which the humanitarian may be inclined to deplore, we must, I think, agree that a certain curtailment of the right to political opposition is an unavoidable concomitant of transitional periods, and that the rigors to which the Russian people have been called upon to undergo have been amply justified in the sphere of concrete achievement. What is this actually saying? That's right. This is saying that purges and gulags and political oppression are acceptable. But you would never come out and actually say that. Instead, you hide that kind of position in this sort of bad writing that keeps people from thinking clearly and deeply and rationally about what you're saying. Here's a much less sinister example taken from some academic literature. I'm not indeed sure whether it is not true to say that the Milton who once seemed not unlike a 17th century Shelley had not become, out of an experience ever more bitter in each year, more alien to the founder of that Jesuit sect, which nothing could induce him to tolerate. What's that saying? Anyone? Interestingly enough, besides being totally incomprehensible, the fourth not should not be there. And the word alien should probably be akin. So this is actually too difficult for even the author to think coherently about what they're writing. So Orwell gives 6 principles for writing with good style. And here they are. He says, never use a metaphor, simile, or other figure of speech which you are used to seeing in print. Second, never use a long word where a short one will do. Third, if it's possible to cut a word out, always cut it out. Fourth, never use the passive where you can use the active. Fifth, never use a foreign phrase, a scientific word, or a jargon word if you can think of an everyday English equivalent. Sixth, break any of these rules sooner than say anything outright barbarous. I think these are interesting rules to think about in terms of how we write, in terms of how we program, but also how we design products and how we design things like APIs. I get a couple principles from this. The first is that a good API is minimal. We as software developers work with massive complexity. We're dealing with maybe thousands or tens or hundreds of thousands of lines of code, functionality that we can't keep in our heads, you even come close to keeping in our heads. And the best way to be able to deal with that problem is to think clear, is to write code, write software, and create products that are simple and minimal and clear. For example, in the Zencoder API, there's about 150 parameters you can pass. Advanced settings for choosing your format, your video format, your resolution, your bitrate, all sorts of little micro knobs that maybe no one ever has to do, or maybe only a couple customers ever have to use. but you can send us a single parameter, and we will transcode a video to probably about what you want. So it's basically it chooses smart defaults. It does smart things with the attributes that you don't tell us. We'll make smart decisions about resolution and bitrate and all that. So all that complexity is there under the surface, and it's fine to have that if you need it. But keep the default case as simple as possible, and then people can layer on the additional complexity that they need. Second principle, a good API will get out of the way. So just as good language and good writing doesn't call attention to itself, it doesn't obscure, it doesn't obfuscate what it's trying to do. I think a good API design is direct, and you almost don't notice it. For example, use REST. If you see an API today that uses something other than REST, that's probably the first thing you're going to notice, and you're going to say, why are they using SOAP, or why are they using whatever it is? I think consistency is a really important principle here as well. If you're going to return a certain kind of response in one situation, always return that response in any situation similar. Structure your JSON or your XML in a similar way so that you don't create inconsistency. Just a little example. HTTP gives us two codes for authorization and authentication. I've seen applications that will kind of mix these. They'll use them inconsistently in different places. There actually is a good reason for there being two of these, but it's kind of it's not something that we should have to worry about. Any thoughts or questions on any of this so far? Great, let's move on. So we're going to talk now about a guy named Dieter Rams. Dieter Rams was the chief design officer at Braun for a long time, and he's one of the most famous industrial designers ever. He's incredibly influential. He was very influential on a guy named Jonathan Ive, who we all know as the head of design at Apple, who today is the company we all think of when we think of industrial design, but 30 years ago it was Braun. Jonathan Ive has took a lot of inspiration directly from Dieter Rams, and I'm going to read a little, read a quick paragraph from an introduction he wrote to a book on Rams. Ive says, "When I was a young boy growing up in London, my parents bought a wonderful juicer. It was a Braun MPZ2 Citramatic H. I knew nothing about Dieter Rams or his 10 principles of good design, but to a little boy uninterested in juicing, I remember the Citramatic he and his team designed with shocking clarity. It was white, it felt cold and heavy. The surfaces were without apology, bold, pure, perfectly proportioned, coherent, and effortless." And see if you can create a picture of anything here. It was clearly made from the best materials, not the cheapest. At a glance, he knew exactly what it was and how to use it. It was the essence of juicing made material, a static object that perfectly described the process by which it worked. It felt complete and it felt right. So imagine for a second if Apple were to create a juicer, which I don't expect they will, but if they were, what would it look like? Maybe something like that. You can see the influence that Dieter Rams had on Apple's designs. Here's a few other examples. On the left, we have a Braun product, and on the right, we have an Apple product. So I'm going to let Dieter Rams quickly go through the 10 principles here, see if this works.
Gutes Design.
Can everyone see the subtitles? This is in German. So.
Gutes Design macht ein Produkt brauchbar.
Subtitles, yes, no?
Gutes Design ist ästhetisches Design. Gutes Design macht ein Produkt verständlich. Gutes Design ist ehrlich. Gutes Design ist unaufdringlich. Gutes Design ist langlebig. Gutes Design ist konsequent bis ins letzte Detail. Gutes Design ist umweltfreundlich. Last but not least, gutes Design ist so wenig Design wie möglich.
So we're going to talk through some of these principles of industrial design and how they relate to our jobs building APIs. First, good design makes a product useful. I think sometimes we think about design as being something superfluous, right? It's like additional style added to something. Maybe you can take it or leave it, throw a little color on it, that's the design. But that's not really true. Anything ever created by a human is designed. It's just that there's good design, intentional design, and maybe bad design. And good design helps make things functional. It helps empower the people who are trying to use it. It helps make maybe every aspect of how something could be used, make it possible. I think extending this a little, a key principle of design and industrial design is that you want to design for the extremes. You don't just design for the average case, how the average user might use something, but you actually design for the edge cases here and here. And if you do that, the middle will probably take care of itself. So for example, if you're thinking about API design, let's say you're building an API to like a phone system, like Twilio or something like that. Think about that product and that API. Think of how a power user, like an expert user, would use that API. Someone who actually has built telephony systems internally. How do they encounter your product? Or many of us here probably deploy to Linux and are Linux users or Mac users. How would a Windows user encounter your API? It shouldn't matter, right? An API should be totally agnostic to the language or the platform that's accessing it. Or think about how like the wrong customer would use your API. Someone who shouldn't be using it, they're not your target market, they probably don't even, maybe, they probably don't know how to do it. How do they encounter it? So like at Zencoder, we are an API-only product, and that's intentional. We never stood up a web page where you could upload a video, get it transcoded, and download it. And the reason is we didn't want like 10,000 people doing one-off transcoding on our platform. That would be a support headache. It wasn't the product that we were trying to design. And actually making that decision not to even allow that helped segment users. So the only users who could use our product were programmers. In terms of extremes, think about scale. Think about how will a user use your API at not normal usage, but huge usage, either intentionally because they're big or accidentally because they write an infinite loop that keeps exercising your API over and over, which has happened to us quite a few times at Zencoder. Think about how a bad programmer would interact with your API. So someone who doesn't really know what they're doing, but maybe thinks they do. This is actually almost anytime we have an unhappy customer or a customer support issue at Zencoder, it was because they didn't really know how to program, but they thought they did. So they would try what we're doing, and they'd say, it doesn't work, it's horrible. In fact, it worked fine, it was properly documented, but they didn't know what they were doing. So this is something that we've spent a lot of time trying to design our system to be used by everyone, but it doesn't always work. Here's actually an email we got. We had someone try to use our system and didn't understand how we do URL encoding, which is kind of a complex thing. But we very clearly laid it out and told him how to do it and showed him documentation. And the guy just didn't believe that we knew what we were doing. And he sent us this email. He said, Ben, who's one of our customer support guys, Ben, I went back over everything again and again, and it still didn't work. So forget it, Ben. Please see that my credit card is not charged, Ben. I have no interest in your services, Ben, for this PW cart. He was integrating with like premium web cart, which maybe tells you something about him. Maybe later for something else, but I doubt it, Ben. I find your service lazy and incomplete. Your support arrogant and not very knowledgeable. Looking forward to never seeing your name and company in my inbox again. Richard. Yeah, I left his last name off, but you can actually find him on Twitter. So anyway. If you design for the power user and you design for this guy, you will have everyone in this room covered with your product. Next, good design is aesthetic. This is what sometimes we think about as design. Design is making things beautiful. And that is actually entirely true. Good design should make products beautiful. Who knows what this is? What's that? VB, camel case, what else? Hungarian notation. Who thinks Hungarian notation is beautiful? Raise your hand. We're all here today as users of Ruby, and Ruby is a language that was designed by Mats in order to make developers happy. And a big part of how Ruby does that is actually being just a really elegant language. It's probably the most beautiful language, at least I've ever encountered. Even people who hate Ruby usually give us that. Good design makes a product understandable. Let's look at a kind of fake API here. Let's say you have an API that someone sends this request to you. They give you an API key of does not exist. What do you do? If you want your API to help the user understand what's going on? Well, you could return like a 500 internal service error because you didn't handle the case of a fake, incorrect API key. That's not very good. So you can do better. You can choose something like 401 unauthorized and say, we were not able to authenticate you because you didn't give us valid information. But you can go further. You could return error message. You could say API key not found. At this point, someone has probably a pretty good idea why their request failed. But you could also provide some validation information. API key may not include spaces. Now they know not just that the API key is bad, but they know something about why it's bad. Finally, why not do something like this? API key not found. Please log into this URL to retrieve your API key. Here's another example. What's wrong with this request? Missing a comma. Anyone ever been bit by that? Yeah. You can return a 400 bad request. This is a malformed request. They sent this random bit of text, and it wasn't JSON. We couldn't parse it. But why not go a step further and maybe include like a lightweight JSON validator in your API? So you can actually tell someone exactly where what went wrong. This is the output taken from a sample parser. I think there's better ones today that actually give you a little more insight into like, there should be a comma there. But this is easy to do. Next, good design is honest. A good API shouldn't leave ambiguity. A good API should show clearly what's happening in a system, should give full insight into things when they're working, when they're not working. So for example, if you send back a 200 OK, make sure everything's OK. Never send this back with like an error message that says, actually, it didn't work. This is a perfectly valid thing to send back, and everyone integrating with your API should handle this case. If the service is unavailable, what do I do? It's clear, it's obvious, it's honest, and the consumer of the API can maybe queue the request for resubmission. What about this one? What do you do if you get a request timeout? Let's say you're processing a credit card and you get a request timeout. You have no idea. This should never happen in a well-designed API. Next, good design is unobtrusive. I'm going to show an example that's not at all related to API design, but I think it's kind of cool.
It's really important in a product to have a sense of the hierarchy of what's important and what's not important by removing those things that are all vying for your attention. An indicator has a value when it's indicating something. But if it's not indicating something, it shouldn't be there.
I think it's kind of cool. It's harder to do this sort of minimal, unobtrusive design than to not do it, but it makes products better. Good design is long-lasting. Who knows where I'm going with this? Version your API. When you first start an API product, maybe it's a startup and you don't know how far it's going to go, or it's an internal project that you don't know if it's going to be used. You don't actually have to do anything except scope, just namespace. That's all you have to do to version your API. You don't have to build a big versioning apparatus. If you don't start this way, you're going to encounter a lot of pain when you realize, and you will realize if your API keeps running, that at some point you have to make a change that you can't just shoehorn in. There's lots of ways to version an API. This is one of them. I'm not going to get into issues there. Another one, this is simple, but unique UUIDs make much better primary keys than, say, like incrementing integers. There's a lot you can do at scale if you are using GUIDs as keys that it's harder to do if you're relying on, let's say, your database to give you back IDs for records. Finally, good design is as little design as possible. Kind of sums up Dieter Rams's philosophy and also corresponds with Orwell's thoughts. So we're going to add a fourth guiding principle here. Good design is minimal. It gets out of the way. It designs for the extremes. Good APIs are predictable. Without even having seen an API, you should be able to make a pretty reasonable guess as to how it would work. Let's look at an example. Who here is integrated with the Stripe API? Okay. Those of you who have, be quiet for just a minute here. Those of you who have not used Stripe before, how do you think the Stripe API works? What's the URL that you hit if you want to make a transaction, if you want to charge someone money? What are the parameters you have to do to successfully charge someone something? Here it is. HTTPS, that makes sense, right? Credit card processing is probably should be secure. API.stripe.com, that's pretty easy. v1/charges. Everyone here probably could have guessed pretty close to that. Maybe you wouldn't have gotten it, but fortunately they have documentation. You shouldn't make your users guess. You should be predictable, but don't make them guess. It requires an API key to let Stripe know who is charging money, an amount, a currency, and then either a customer ID or credit card information. That's it. That's probably pretty close to what we would have guessed if we would have written it out. Questions or thoughts at this point?
Just from before, I was curious what that clip was with the Mac.
Yep. The question is, what was the clip? So both the clips I showed were from a movie called Objectified. Has anyone seen it? Objectified? So I think it's by the same people who did Helvetica a few years ago. Is that right? It's good. It's a good movie on design from a lot of different angles. It's on Netflix. Great. So last, we're going to look at something called the Kano Model. This is a product development methodology created by Noriaki Kano, who is a Japanese professor who did research into customer satisfaction of products. And he basically looked at what are the attributes and features of products that have high satisfaction or low satisfaction, and how do the different features correspond there. Here's the model. We'll look at it in a little detail, but basically there's 4 different ways you can classify an attribute of a product or a feature. The first is basic needs. These are the things that you have to have. In the model, this is the green line at the bottom. If you don't have a basic need, people are going to be dissatisfied. If you do have it, people aren't going to care. They're not going to notice. It's kind of a neutral if you do have it. For example, think of like the best possible bus driver. Just in their capacity as a bus driver, not like a bus driver who fights crime. What is your happiness and satisfaction after stepping off that bus? Okay. What about the worst possible bus driver? What is your happiness or satisfaction after stepping off that bus? I think in API design, I think a good example of a basic need is uptime. If your service is down, everyone cares. Everyone is upset. If your service is up, people don't get excited that you're up, unless you have a lot of problems, like Twitter maybe 2008. Instead, they don't even notice. They don't even think, oh, the service is available right now. Anyone have other thoughts on what kind of basic needs features of APIs might be?
I mean, it does what it says. It's just clear.
Sure. Yeah, just working, doing what's advertised. Whereas if you don't do what's advertised, if you ask to charge $20 and you charge $40, you're probably going to be dissatisfied.
And no unexpected side effects.
No unexpected side effects, yep. What else? Principle of least surprise. Fast? Not a performance bottleneck. Yeah, if you can't keep up with a customer people are going to be upset, but if you can, they're probably not going to notice. Was there something over here? Complete. Say more. Say more. Complete. Sure. Yeah. You didn't release half of the payment system, but it actually works for every user that you might have or every type of interaction. Flexible. Let's move on. We can come back to all of these at the end. The second type of feature or attribute are what Kano calls performance needs. These are one-dimensional. This is in the model. This is the blue kind of straight line. These are things where if you don't have them, people are upset. If you maybe are average, people don't notice, and if you do it really well, people get excited. What are some thoughts on what could be performance needs in an API? Speed. I think for it depends what you're doing. I think for something like long-running processes, like video transcoding, this is absolutely one. If you are slower than average, people complain and say you're slow. If you're faster than average, people get excited and say that you're fast. What else?
Would this also fall under like the simplicity and being able to integrate with the API? Is that a performance metric?
What do you guys think? Do you guys simplicity, ease of use, and integrating the API, is that something that scales linearly or follows a curve? I can see a case in aggregate for that being a linear kind of performance need. If it's exceptionally hard versus exceptionally easy, people will care. I think quality is an example. So in video transcoding, if you compress video poorly and everything looks bad, blocky, people are going to be upset. If it looks great, if you compress better, then people get excited. I think anything related to cost or revenue would fit in here too. So if your API, if price scales, or let's say you're a revenue generating API, you're an ad service or an affiliate network or something. If you get someone more money, they're going to be more excited. And if you get them less, they're going to be less excited. Other thoughts of these kinds of features? Predictable. Having a consistent response. That's something that, how is that a linear scale? Sure. Sure, yep. Yeah, so being able to hit a target. Bandwidth? Sure, it's bandwidth would have a lot in common maybe with a speed or a attribute. Next are features to which users are indifferent. They don't care if you have these or not. This is sort of the gray box in the middle. If you implement these, people don't care. If you don't implement them, people don't care. What are thoughts of indifferent features in APIs? What's that? Soap? Who here is indifferent to the use of soap? What else?
Is it stuff that's not core, that's tangential?
Stuff that's not core, tangential, sure. Maybe features that, if you're never going to use a feature, you don't care as much about it. So then this is maybe one that's different for different users. Some users would experience something as a basic need. Some might be indifferent. What's that? Sure, yeah, great point. Undocumented features, if you build something awesome and deploy it and no one knows, they're not going to care. Yeah. Google Reader? Are you saying that users are indifferent to Google Reader, or Google is indifferent to Google Reader? All right. The last category are what Kano calls delighters. These are features that are attractive and exciting. This is the red line at the top of the graph. If you don't have these, people don't care. And if you do have these, people get excited. These are, I think this is where the Kano model is most interesting. I think oftentimes we think about getting to feature parity or performing better, but actually there's a lot of interesting things. Actually, a lot of the products that we get excited about and love are happen because they have these kinds of features. So in Zencoder, this feature for us was our API request builder. We built this along with the first version of the product. We have kind of a complicated API, like 100+ settings. So we basically built a tool that lets you explore every setting in the API and composes your API request. You can copy and paste that into your application, and that's your integration. This was maybe a week of work. It was some complex JavaScript, but it wasn't that hard. But people consistently, when they give us feedback on our product, this is one of the top two or three things that they talk about. I'm going to read some feedback on this. We got an email a while ago, unsolicited, from a customer who said the following. I know the following statement is going to sound dramatic, but it's the truth. Zencoder seriously uplifted my entire day. The API is really well designed and has documentation for not only what each value should be, but also for what an example input or output would look like. I spent the earlier part of the day working on a web service that was the complete opposite of those things. So when I started digging into Zencoder, I felt like I was witnessing a double rainbow. Then, when I found the API builder, it went beyond a double rainbow to a level I can only imagine is equal to witnessing a unicorn birth. So that would never have happened if we just built a service that performed and met basic needs. That happened only because we had spent the time to do sort of unnecessary things that made our product different and got users excited. I think another example of this, and this is really, really sad that this is the case, but good support for software products, for services, for APIs, I think is this sort of delight feature. Hopefully that won't always be true. And over time, in theory at least, the differentiator features become basic needs. So it was pretty amazing when they put Wi-Fi on airplanes, right? 10 years ago, we would have said we would have sought out those flights. Now, if the Wi-Fi is down on an airplane, you get upset. That's an example of something going from an excitement feature to a basic need. But customer support, I think, is something here. And anyone building an API product, support pays massive dividends.
Sorry, I just have to ask, why red instead of green for delighters?
Why red instead of green for delighters?
Why did you switch those two colors?
I just stole this off Wikipedia, so yeah, I don't know.
That's very context sensitive. There is no Wi-Fi on flights in Australia. The fact that you have internet when you're flying is fucking amazing. People complain when it's not there.
It's true. It's true. It's true. If anyone hasn't seen the Louis C.K. bit on that, I think it was on Conan, it's pretty good. It's pretty good. What are other thoughts of these sort of delighter features? Maybe specifically, what have you seen in great APIs or great software products that fits this category? Yeah. You feel like you're talking to another programmer? In support or in what sorts of?
This is what I want you to do.
Right, sure. Kep?
The intelligent defaults of Zencoder are good. Just give it an input, and you get 3 or 4 good encodings.
Intelligent defaults. So if someone is actually, if someone tries something out and is surprised by maybe the quality or the success of what happens, it could be this kind of feature. They might expect that they have to do a lot more work and find out that they don't. Yeah.
Documentation's like populated with stuff relevant to your account. It just reads like it's for your account specifically.
Yeah, great. Yep, documentation that's actually populated with your account. So put your API key in the sample request or something about your usage profile. What else? What's that?
A wrapper,
Sorry.
like an API wrapper.
An API wrapper? Okay, like a Ruby library or? Sure, Kev? What else? Logs? Request logs, sure, yep. Yep, you can actually, if you're designing an API, why not store off every API request and let people go back and look through them, especially the failed ones, find out exactly what they sent that failed. Maybe provide some ability to retry. So let's say it's a push notification, like replay that notification. Development APIs? Sure. Yeah, like a sandbox API, an API that you can play with without, paying money. Yep. What are some like getting specific, what are some great APIs that people have used and why? Stripe. Who has used Stripe? Raise your hand. Who likes Stripe? I don't think any hands went down. It's pretty cool. Stripe took something that we'd all been doing for a long time and actually just made it good. And that making something horrible good kind of follows that red pattern there. What else? What's that? SendGrid? SendGrid? Twilio? Zencoder? I'll talk to you later. Kind of wrapping up, Kano found in his research that the right place to focus in building products, if you want to increase customer satisfaction, you invest in these. You invest in delight features and maybe a handful of performance features. Everything doesn't have to be high performance, but you want a few things, you want as many things kind of in the top right of the chart as possible. Actually, spending time satisfying basic needs doesn't do nearly as much to make customers satisfied with your product. Getting back to the principles, we've talked about minimalism, we've talked about getting out of the way, we've talked about designing for extremes, we've talked about being predictable, and the fifth is excite users. APIs are products nowadays. APIs are not just technologies. And so if we want people to use them and get excited about them, we have to invest in those kind of things. Any other thoughts before we wrap up? Yep. A concrete resource for specific things. How to build a great API. There's been a lot of activity in conferences and blogs over the last couple of years on API design. Anyone know a great talk or post or something that would be good follow-up from this? White House GitHub. Cool. Kev? Design of Everyday Things, which is who's the author of that? Norman, is it? What is it? Yeah, so a classic book on just design in general, which could be applied to software design, product design, API design. All right, thanks everyone.